Hey, what's up and how's it going? This is Toby and today we're going to build a truly amazing cross-platform WebXR experience, and you can already see it running here on the Meta Quest 3 in augmented reality. It will also work in virtual reality, and it will even run on any other device such as smartphone, tablet or computer using Web3D, so it's going to be truly cross-platform. All of that is going to be built within one single project and one single code base, so we don't have to do any kind of builds or maintain different kind of projects. It's going to be all within one single project. After this tutorial, you'll even be able to send a link to all of your friends and family members, and they can open it up and immediately start enjoying your WebXR experience within their browser, so no app or download required. I want to make this tutorial as beginner friendly as possible, but you'll definitely have a huge advantage if you have a little bit of experience using game engines such as Unity, and of course having some basic coding knowledge, ideally in TypeScript. But I'm gonna do my best to make it as easy to understand as possible. So without any further ado, let's get started. The first step is to download and install the software, so let's do that with Unity. If you haven't already, simply go to unity.com and click on download, and then we're gonna get to unity.com/download, and we can here install the Unity hub for Windows, Mac or Linux. So in this case I'm on a Mac, so I'd simply click on download for Mac, and it will then, well, if it's not blocking the download, we need to of course allow that. Download the Unity hub, and this is what we're going to use to actually install and download the editor. So I already installed the Unity hub as well as the editor, but if you open up the Unity hub, it should look a bit like this. And of course you also need to create an account. So if you haven't already, then you can click on this little icon at the top right corner and then create a Unity ID or sign in with your current Unity ID, because you'll need to do that when opening up the hub, as I did over here. And then we can click on installs, and here we can install editor, and I'm going to use Unity 6 version 6.0.0.0.0.39 but using Unity 6, so any kind of Unity 6 version should be fine for this tutorial. But if you want to be super sure, then also go ahead and download exactly this version. So when you click on install editor, you might not see exactly this version that I'm using. So here currently the latest one is 44F1. They'll push an update every few weeks or even days. Again, this version should be completely fine, but if you want really the exact version that I do have, you can go to the archive, so to the download archive, and here you'll be able to search for the version that I do have, which is this one, and then you have the hub installation, click on install, and then it will open up in the Unity hub. Also, when installing an editor, you do not have to select any of those platforms here, as we are using Needle Engine to push it to web. So you can just leave it like this and uncheck all of these boxes. And of course also make sure to have a code editor installed. So this could be Visual Studio Code, but this could also be WebStorm, for example, which I like to use as well. So then next up, let's create a new project within the Unity hub. So let's click on new project and let's select the editor version. Let's make sure it's 6.0.0.0.39F1. And then we want to select the Universal 3D pipeline. We can call it as we wish, so tutorial WebXR game, for example. Make sure to select the organization and to select a location, and then we can click on create project. Once Unity finished setting up the project, let's do a double click on the scenes folder here and rename our scene from sample scene to WebXR scene. Like that. Next up, let's install the Needle Engine, and there's a link in the video description which will bring you to this page over here. The link is an affiliate link, which means that if you should at some point decide to upgrade to Needle Pro, this will also support a channel, just to let you guys know. But Needle is generally, of course, free, and all we do in this tutorial is free as well. So we want to click on login over here. And then you can either create a new account with your mail or sign in with Google, GitHub, or Discord, or you can sign in with your already existing account. So once you're done setting up your account, it looks a bit like this. So this is the Needle Cloud dashboard. And here we can download Needle for Unity, but we can also take a very quick look at the commercial plans. Needle is generally for free, so we can simply go ahead and use it. However, if you would want to use it commercially or deploy it on your own website or server, then you would need to do a premium subscription. However, for our purposes, so hosting it locally using the full features of the Needle engine and even hosting it on the Needle Cloud is completely free, so we don't have to worry about that. So then let's go ahead and download the Unity plugin of the Needle engine. And then in our Unity project, we can go to Assets, Import Package, Custom Package, and then simply select the Install Needle Engine Unity integration and open it up. Then simply click on Import. One thing that will also pop up is this little welcome window, and in case you should accidentally close it, you can always reopen it by clicking here in the top menu on Needle Engine and then open up the welcome window. And then you can also definitely explore the samples. So these are very useful. You can also filter by XR. And here you'll find a bunch of examples how to use Needle Engine in combination with XR. I'd recommend definitely taking a look at the room tracking and pass-through, as well as the collaborative sandbox. So I've tried these two before and they are pretty nice, but there's a lot more, so definitely try out these. And if you want to test us out, you can simply click on Install Samples, and then it will pretty much load this project into your assets here in the Unity project. And you can then see how it was made, or you can simply click on live to see it running within the browser. And you could even open this link, for example, on your Quest device, and then test out, for example, the collaborative sandbox in action. And you don't have to host it or start a server or anything. You can just immediately test it out in the browser. And then what we want to do is go into the Needle Engine menu. Up here, we want to go to the welcome window and we want to add the web exporter to scene. We could also achieve that by doing a right click here in the hierarchy Needle Engine and then add export info for our web export. That would be completely valid as well. So the reason why we need this export info over here is once we are done creating our level, Needle will export this into our web project. And basically within the export info, we can decide things like the compression or level of detail settings. And after we generated our project here, we'll be able to manually click on export to web or even automatically export our current project to the local host, or maybe even push it to the Needle Cloud so that we can send a link to our friends and family and they can try it out on an actual server. So let's click on Generate Project here. So then we quickly need to agree to the Euler of Needle, and after that we can get started. Let's also quickly go to the settings over here and then within our validation window. So we can go to Needle Engine and then Project Validation. Let's make sure to fix the light map encoding over here and make sure that all of these are set to green. So then next up, let's click on Install. And what Needle is basically doing in the background, it's creating a full separate web project, which will basically host our 3D scene and which will later on export all of our 3D objects and our logic basically too, which then can also be separately edited from the Unity project, which is pretty cool. By the way, anytime you hit Ctrl S or you save your project, it will be automatically exported to your local browser so you can immediately start testing it. So let's set up our WebXR scene next. Let's do a right click and create an empty object, and let's call this one XR rig, like this. And then we're going to add component, and we're going to add the XR rig. and also the object raycaster. And then we're going to take our main camera and simply drag this one into the XR rig. Also, we want to create a new empty object inside of the XR rig and call this one WebXR. And here we want to add component and add the WebXR component provided by Needle. We also want to import the XR controller model. And we also want to add the XR controller movement. And here we can already go ahead and set all of these values to 0 because, well, this script here will actually enable to move around with the controller in virtual reality. So for example, you can use the right or left stick to move around. You can also see kind of the explanations over here. So the speed at which the user will move when using the thumbstick, for example. And we don't actually want this because in our application, we want the camera to be static at one position so that the user can use the thumbstick and all the controls on the Quest 3 controller to actually move our character that we'll place in here later on. By the way, one very cool tool provided by Needle in order to find out what these components do is the explain using AI, and you can trigger that by clicking here on the 3 dots, Needle Engine explain using AI, and then a new window will open within the Needle Cloud, and then some kind of ChatGPT will explain to you what these components or scripts mean, and you can also ask more questions. And this is pretty great for understanding generally what those Needle components do. So then let's go ahead and for testing purposes, create some kind of 3D object like a cube. Let's take the game view over here and create a split screen. And then let's take our main camera over here and move it a bit upwards and maybe make it look a bit down. Then we want to hit Control or Command S to save it. So now it's exporting the scene. And then we can go to the export info and we can go ahead and start the server, which will start a localhost server on our computer. Before we will open up the server, let's first of all delete the global volume, which is related to Unity's URP. So we can simply right click and then delete, because we will not need these post-processing effects for our WebXR app. And then let's go ahead and save once more. So it's going to export the project. And then if we once again click on the export info and wait until it's done exporting, we will see it here, finished building. We can open the server and then we will see in our browser our cube, and with our mouse we can move around, we can zoom, and also with the right button on the mouse we can just move left, right, up, down. And if you put this address up here into any other device, such as your smartphone or your XR headset, which is connected with the same network or the same Wi-Fi as you are currently, you'll even be able to open it up and play around with it on this other device right now, which is super cool. All right, so we got our Web3D/WebXR application running on our local browser. Let's next up create the logic for our actual game. So let's close this. And in order to get started with the logic, let's click here on the project folder, then on the assets, right click, and then I'm going to select Reveal in Finder. And if you're on Windows, you can also open it in the Explorer. So we get the folder of the actual project. And then in the path of the project, we do have a folder which is called Needle. And here we're going to have a folder of each scene that we'll create in Unity and basically export. So if we do a double click on here, this is a full-on web project. So this is actually what we're seeing in the browser with the assets and the source folder. So this is just basically a standard web project. And if we're going to take a look here in the assets, what we are seeing here are all the 3D objects from our scene that we created in Unity, which will be converted to GLBs, including the whole WebXR scene. And then if we wanted to add logic to this, we would actually go ahead and put it in the source folder. So in order to get started, let's actually open up this project here in Visual Studio Code or in WebStorm. So for that, let's open up Visual Studio Code. And if you haven't installed VS Code yet, it's very easy to find on Google, so you can just download and install it. Then I can open up a new project and I'm gonna head to the folder where Unity project is and simply go within the needle subfolder, our WebXR scene, and here we go. So we can open this one up. And if we had multiple scenes, we could maybe even take this folder as a root one, but as we will only build one scene in this tutorial, I'm going to navigate here and open this scene up in Visual Studio Code. So here on the left side, we do actually have our project open, which I just showed you in the Finder or the Explorer. And now we could go ahead and write any kind of logic and put it here in the source folder. However, to write logic, we first of all need to have some kind of level or some kind of objects, actual objects in our scene. And let's go ahead and do that first. One great advantage of Needle working with Unity is that if you're already a Unity developer, you can use all the assets that you've already acquired or collected in the Unity asset store, such as 3D objects. So to quickly get assets, we can visit assetstore.unity.com, and then under 3D, we could, for example, select the characters tab and then say we want 3 characters. And basically here we could download anything. But of course, we always need to be aware that when using web-based projects, we don't want to go for maybe super photorealistic avatars or something, because they usually have a big file size and then the page is going to take forever to load, even though we do have a kind of auto level of detail system with the Needle that will already compress all the files and make the size smaller. So for this tutorial, I chose 2 assets which are completely free. So this is the Battle Royale Duel Polyart. And again, I always put all the important links in the video description, as well as the stylized free skeleton from Thunderforge Studio. Both of these are free and animated and they look really nice. They are also low poly, so they will not take too much space in our web application. So then we can go ahead and add these to our assets. Same thing here, add to assets, accept. And then back in the Unity editor, we can go to Window, Package Manager. And then under My Assets, we can search for the skeleton. And so we do have the stylized free skeleton, and we can import this one to the project. And if you haven't downloaded already, you'll first be asked to download it. And then we can also import the Battle Royale Duo characters. So then let's close the package manager. And then let's click on the cube and select the scaling tool over here. And let's actually turn that into the ground plane for our level here. So let's make it a bit flatter like this, but therefore a lot longer and wider, so that it's almost a square, something that we can use as the ground plane for our level. And then let's also place some new cubes here. So right click, create cube. Let's duplicate that 2 times. And let's move these cubes, which could serve as some kind of obstacles, into the scene. So we're kind of building a little action jump and run game here, and we definitely need some cool obstacles for that. So let's move it along a little bit, like that. Let's make this a bit higher, one a bit lower, and let's also take the third one Let's scale it like that. And yeah, maybe put it somewhere over here and make this one a bit like thinner, like that, so that you can also move in between those obstacles. All right, so how does that look? I think not too bad. So we have some space here to spawn the characters and then some space in the middle to walk in between, maybe like this. So let's also remove the split screen that we have here by moving the game view back onto the same tab as the scene view. So we can freely move around here and have a bit more visual space. Let's also create a new folder down here and call this one materials. And let's do a right click, create, and create a new material. And let's call this one obstacles. Let's turn it maybe into a yellowish, brownish color like that. And then let's drag the material onto the obstacles so we can see them quite well. And then maybe let's also create another material, and this one we're gonna call ground. And the ground looks very gray right now, so maybe let's make it rather a bit dark bluish. And let's drag that on here. So that already looks a bit better. Next up, let's drag in the assets that we just imported. So we do have this Battle Royale Dew, and we're gonna go to the prefabs here, character. So now we can drag in either the female or male Polyart. I'm just going to take this one. And here we go. It might be that for you the texture is still pinkish. And this is because these characters come with the older Unity built-in render pipeline materials that were still with Unity in 2022 and earlier. And all you got to do then is go back into the Battle Royale Duo, go to the materials here, select all of them using Shift. Then you can go up to Edit, Rendering, Materials, convert selected built-in materials to URP, proceed, and then they should look like in my editor right here. So this is a little bit big. So let's actually create a new empty object which will hold the character. So let's call this one character. And let's set this one first of all to 0, 0, 0, and then drag it somewhere close to here. Then let's drag in our prefab into this empty object. Set the prefab position to 0, 0, 0, and then set the scale to something like 0.5. The reason why we're doing this is because we'll later on add a controller to this character model here, which will control, for example, the speed with which this character is moving forward and backward. And if we would later on change the actual scale of the character while the script is already attached, which controls movement, it could also affect the speed with which the character is moving. And we don't want that. And this would also be an easy way to swap out the character model while not having to then again attach all the scripts. So let's drag that up a little bit so it's somewhat on the ground like that. And next up, let's also import our skeleton models. So for that, we can click on the skeleton folder, prefabs, skeleton, and drag that in here. Here we do have the same issue with the pink textures, so go back, materials, select all of them, edit, rendering, and then convert to URP. Then again, we're gonna do a empty, gonna call this one skeleton, maybe enemy or something. Set it to 0, 0, 0. Then we can drag in the skeleton prefab and also set this one to 0, 0, and 0. Then we can once again decrease the scale to, for example, 0.5. Think that looks good. And then drag the whole character up so it's standing more or less on the ground. Okay, cool. So now we have both of our characters in the scene, and next up what we want to do is we want to create a character controller so we can move around with our little character over here. Back in our Visual Studios project, we can do a right click on the source folder, click on new file, and then we can call this one, for example, character controller. And then don't forget the TS for TypeScript. And so let's begin by creating a new class. So we can say export class and then character controller. And this one will extend behavior. And we have behavior here within the needle tools. And this is the same as creating a mono behavior script within Unity and C# if you've already done that in the past. So this character controller script will have three options basically. So the first one will be that we are on a mobile platform such as a tablet or a phone, that we are on a desktop platform such as a laptop or a PC, or that we are in XR, for example, within the Quest or the Pico or the Apple Vision Pro as three examples. So for that, we want to create also three booleans. So we're going to create is mobile, and this one will be a bool, which will be false from the beginning. Same as is desktop will be false from the beginning. And then also is XR, which will be false from the beginning on. Then let's create a new variable that we want to call keys pressed. And so this one will be a dictionary. And this one will help us to track which keys have been pressed on the keyboard, but I'll come back to that a bit later on. Then we also want to store the movement speed. And the jump force. And we also want to create a variable which says is grounded, because later on we'll also implement jumping, and we only want the character to be able to jump if it's actually on the ground. So that will also be a boolean, which we're gonna set to true from the beginning on. Then we'll also create a new spawn position. So this one is going to be a vector 3. And this one we'll use to respawn the player if it, for example, fell down. And I think looking at this, we can actually go ahead and already set the jump force to here in the variables at the very beginning, and we don't need to actually set this one in a separate method. So then we can create a new function which we're going to call onEnable. And this one is an event function which will work the same as any kind of event functions in Unity. So this will trigger at the very beginning before the actual game or experience even starts. For that, we want to first of all go and copy the current position of this object. So we could say this spawn position, and let's just say copy. And we want to say this.gameObject.position. And so even before the game starts, we will save the current position of the player. So then in the onEnable method, what we want to do next is we want to check for the device type. And for that, we're going to create a function in a second that we're going to call check for device type. And this will be an asynchronous function, and then we're going to use the then keyword. And if we checked which device type it is, then we could say if this dot mobile, we're gonna do something, else if this dot is desktop, we could do something else. And finally, if this one is XR, we will do even something different. But before we're going to decide what we'll do then, let's first of all implement the check for device type method. For that, let's create a new async method and again call this check for device type. And to find out if XR is even supported, let's create a new constant and call this one XR supported. And this one will await this dot is XR device, which we're also going to implement in a second. So let's create a new async method here, which we're going to call is XR device. And this one will return a boolean. So let's set this as a promise, as it's async. And we're going to say if navigator.xr, so if that actually exists, then we want to try, and we want to return await navigator.xr.is session supported of immersive VR. So in this way, we can find out whether we are dealing with a virtual reality device, as we are kind of figuring out within the browser if a immersive VR session is supported. And this will only happen on XR headsets. Otherwise, we want to catch it with the error, and we're going to say console.error XR check error. And we also want to return false. And then if there's no navigation XR in general, we also want to return false. So that in case that there's a immersive VR session supported, we'll return true, and otherwise we're gonna return false. And then let's say if XR supported, we're gonna set this dot is XR to true. And otherwise we want to say this dot is mobile is equal to, and here we can use the device utilities, and we're gonna say is mobile device. So this is pretty easy to do. And then if this is not a mobile device, then we can say this is desktop, is device utilities, is desktop, like that. So going back up to our onEnable function, if we checked for the device type and it's a mobile device, we again want to call a method that we'll just create in a minute, which we might call setup mobile controls. And if it's desktop, again, we want to set up the desktop controls. And if it's XR, we don't actually have to do anything, but I'll explain that in a bit. So then let's create the method setup mobile controls. And this method is going to be really interesting because it shows how we can combine traditional HTML elements with kind of the Unity 3D level that we built in our editor. So once again, we are going to call a method that will create next up, which we'll call create mobile joystick. So this one will be the method that controls the player position. And we'll also call another method that we'll still need to create, which will be the mobile buttons, which will then allow us to shoot and jump. Let's begin with the mobile joystick. So create mobile joystick. So what we will do now is we will create a so-called joystick zone. So we're gonna simply create basically a new HTML element. We want to call this one joystick zone. And for this one, we're gonna say document.create element. And we want to create a new div. And we want to set the ID of the joystick zone to joystick zone. And then we want to manipulate the style. So we can say joystick zone dot style. So we are pretty much creating just a standard HTML element right here that you would, well, usually do in any kind of website. And we can go ahead and say we want to change the position. And we want to set this to absolute. We then want to change the bottom spacing basically, or I think it's not the spacing, but kind of the offset that we do have from the bottom and from the left. So it's positioned at the bottom left corner with 20 pixels of offset from each of these sides respectively. Then we want to set the width to, for example, 150 pixels, the height to 150 pixels. And we also want to set the Z index to 100, which means that it will show on top of the 3D application that runs on our actual phone. Next, we want to go ahead and append this HTML element to the body. So append child, our joystick zone. And then we want to create a so-called joystick manager. And for that, we are going to use the JavaScript library, nipple.js, which is also something that is not really related to Unity, but thanks to the needle integration, we can just use any kind of JavaScript library and combine it with our project, which is really cool and opens up a whole new world. So let's create a manager, and we need to go into our library. And I think we'll need to install that first. So for that, let's go ahead and go into our console, which we can open up by clicking on this button, I guess. And then we can say npm install, and I think it's nipple.js. And then once it's installed, we can go up here and say import nipple.js from, and then we should find it here. Yeah, perfect. So we want to trigger the create method here, and then we want to pass in some options. So the zone is going to be the joystick zone that we just created, so the HTML element. The mode is going to be static because we wanted to stay at the same position on the screen and not move. And then the position will be from the left, from the left, going to be 75 pixels. And then from the top, it's going to be 75 pixels as well, which is also precisely half of our width and height. The color is going to be white. And then we just need to put a semicolon in here. I don't know if we actually need it, but I just like to do it. I'm really used to C#, so that gives me a fuzzy, warm feeling. Next up, we want to access the manager and we want to say on move. So this is basically an event that we are using, which will kind of listen to any kind of movement of the joystick that we are using. And so on move, we are basically going to take the kind of event data here. So these arguments in. And now we want to kind of set the direction in which the character is supposed to move. And to have that separate actually from our desktop controls, let's go up here and create a new variable, which we might call mobile move direction, which is going to be a vector 3. And then down below, we want to go ahead and say this dot mobile move direction. And we want to set this one, and we have the X, Y, and Z here. So let's go into the data and then into the vector. And we want to set the X to the X. The Y will be 0 as we want to map basically our forward and sideward movement, but for upward movement, we're gonna use the jumping later on. And then we're gonna say minus data dot vector dot y as for the z movement. And then in the manager on end, we will say this mobile move direction set to 0, 0, 0, like this. So next up, let's continue with the create mobile buttons function. So we're just going to put that under the mobile joystick. And here we're going to create 2 buttons, one for jumping and one for shooting. So as we've already done before, we're going to create a button container. And we're going to create a new element, so document create element. Gonna again do a div here as our overall container, and then we're also gonna assign this container an ID. And we're gonna call this one mobile button container. And then we also want to set the CSS styles here. So button container and style CSS text. We want to set position to absolute, bottom 20 pixels. Then we're going to take the right as we want to align this to the right side, 20 pixels, display flex, flex direction, gonna take columns, the gap will be 10, and the z-index will be 100. Then we create another const, call this one shoot button, and this will be, as the name already says, our shooting button. Want to create a new element, and we call this one button. And then we're going to say shoot button ID, this one equals to shoot button. And then we want to once again set our CSS text. So shoot button dot style dot CSS text. Set the width to 80 pixels, height 80 pixels too. Want to set the right to 20 pixels. We want to set the border radius to 50%. The background color, want to set this one to orange. And the border, we going to set this one to none. Finally, the color can be white. Font size, let's set this one to 16 pixels. The font weight to bold. And the cursor, we want to set to pointer. Although we probably won't need that as we will only use it on mobile. Then for the shoot button, let's set the text content to shoot. And on click, we want to trigger a new function that will also, as always, write just in a second, which we're going to call trigger shooting from position. So then we want to create the jump button. For that, once again, create a new constant, call this one jump button. Then again, go into the document, create an element, call this one button. And then go into the jump button ID. And again, set this one to jump button. Then we want to go into the style, so jump button dot style. And then the CSS text, as always, want to set this one. Then we can already copy some of those CSS attributes here. So let's first of all copy all of them. And so width and height is going to be the same, border radius 2, color will be blue, and the rest is going to stay the same, I think. And then of course we also want to set the text content, and we want to set this one to jump. And then of course we'll need to add the interaction by saying jump button on click. And we want to then simply add here. And then we want to simply add a function, which we'll simply call jump and also create in a minute. So then of course we'll still need to append those elements. So we can take the button container and append child. We're going to select the shoot button, and we're also going to go into the button container and append child the jump button. And finally, we need to go into the body of the website that we're going to create and host. I'm going to go into the append child and append the whole button container with both buttons. Next up, let's implement the jump function. So we can simply copy and paste this one here. And then first of all, we want to check that if is grounded. So basically, if is grounded, if this is false, or can simply put a exclamation mark in front here. So if it's not grounded, if we are already jumping or in the air, then we want to return. And otherwise, we want to access the rigid body of the character. And I think we'll still need to, yes, we still need to create a variable up here. So for that, we'll create a serializable field. And we're going to then drag inside of the Unity editor the rigid body of the character. And I think we'll still need to add that anyways. So we're just going to call it RB, and this will be of type rigid body. And of course, we'll need to put an exclamation mark here, because otherwise TypeScript is going to complain that this variable is not assigned or might not be assigned. And so with this exclamation mark, we kind of promise that we'll definitely drag something in there in the Unity editor. So then back in the jump function, we're going to say this dot rigid body, and if we do have a rigid body, we want to apply a impulse of a new vector 3, and we are going to apply this on the y-axis with our jump force, and And we'll also need to put in true so that needle makes sure that the rigid body is actually active. So then we want to set the is grounded to false. And then we want to set a timeout function so that after after a certain amount of time, this is grounded is being set to true again. So for example, we can set this to 800 milliseconds, so 0.8 seconds basically. But we could also play around with this value to make sure that we can only jump again once we're on the ground. Next up is the trigger shooting from position method. And we're gonna declare this one here. But as we're gonna handle shooting in a different script, we wanna just leave that empty for now. Before we're gonna set up the desktop controls, let's actually try and test out if things are working. So let's comment this out. And then within the Unity editor, let's select the character and let's add a rigid body. We can also add a box collider. Just need to make sure that we'll adjust the position so that it's kind of fitting to the character model. So let's go to the side view. Let's make this orthographic. Yeah, and maybe make this a little bit thinner here, like that. From the other view too. And then from the top, this looks good. All right, so we have a rigid body and box collider. We can also add the rigid body data as well as the collider data. And this will actually help us, or these are some more detailed settings that we can then select. And this is valid for many components, which are proprietary for Needle or for Three.js, which Needle is based on. And so we can have some more settings that will finally be added in our WebXR experience. Finally, to make sure that Needle will create a C# code reference for the character controller or for any script, we'll still need to drag this script into the scripts folder and move it over there. And next time we're gonna immediately start creating a script within this folder, because that's the way that Needle will actually know that we want to use this script inside of Unity as well. So while skipping over these CSS texts, I actually found that we are missing some colons here and up here too. So then to access our script within Unity, we can click on the Needle folder and then we find the components codegen. And here we do have a reference script basically, which is going to reference all of the variables that we created here. We can then drag it onto the character controller. And all we need to do now is to drag in the character once again with the rigid body component. So after the export has been finished, we can open up the WebXR application onto our mobile phone. So we could open server, then we can go ahead and copy and paste this web address over here and open it in our phone's browser. And now if we open up the scene on our phone, we can actually see a joystick on the left bottom corner, as well as a shoot button and a jump button. And if we click that, we can see that the character kind of lifts off like a rocket. However, also the move joystick is not working yet. And this is because we haven't implemented any real movement yet. We're only setting the move direction, and this is what we're going to do next within the update function. But we can already see that kind of the UI that we created within HTML is actually working, and it's pretty cool that we can kind of mix up this Unity editor scene with our just standard HTML buttons. If you're not able to test out your Needle project using the localhost, what we just did a minute ago, you can also use another option, and this is to upload it to Needle Cloud. And this will actually then publish your project online, so you'll get a link. And this link can be opened up on any kind of device and any kind of network to experience your WebXR app. So you could potentially send this to your friends and family, and they'll just be able to open it up and try out whatever you've built. So let's do that real quick and test out how that works. So all we got to do is to upload to Needle Cloud, and this will once again export the scene. It will take a little bit of time, and let's make sure to make this readable. And then after a few seconds or minutes, depending on the speed of your computer, a new window will open up, and you can see here that we're now on a web address. And if we put this address into any kind of browser on any kind of computer, it will open up just this scene. So from now on, you can simply test it on all of your devices, even if they are in other networks, or even send this to your friends and family, which is super cool. By the way, we can see that something is wrong with the shadows, and we're gonna fix this error just in a second. So the lights that we know from Unity, which show the shadows over here, work a little bit different in Three.js, which is kind of the graphics engine that Needle is built with. And for that, we want to go to our directional light and add light shadow data. And this will basically reveal further information that does not directly belong to Unity, but is integrated into the Web3D/WebXR stack, which is the shadow width, height, and distance. And so the reason why we didn't see shadows here on the character is because we only basically enabled shadows within this little square here. So what we can do is first of all reposition the light a little bit, and then increase the shadow width and height to 15 and 15 maybe. So let's take a look if we click on the light once again. And yeah, so it seems like it's now covering kind of the whole area here. We also don't need the shadow distance to be 300. Maybe just keep that to 15 or something. That should definitely be enough. And so we do have everything now inside of this light cube. Now, if we save the scene and then go ahead and test this in the local server. By the way, if we wanted this to be on the actual cloud, so the link that we just created, we would need to upload this once again. If we wanted to test it locally, we can just once again open our server. And now we should see, yes, we do have shadows over here and also shadows over here. So lighting seems to be better than before. Back in the character controller script, we want now to implement the update method. So this will be the method that checks on any given frame if some kind of input has been done, and will then accordingly move the player in the specific direction. So let's create a new method somewhere here in the middle, and let's call this one update. And first of all, we'll later on need to check if player fell. We will implement this method a bit later, but just let's put it in here so we will not forget it. So let's call check for player fell down. So then let's do a method to check whether we are on a mobile device. So we could say if this is mobile. Let's create a new constant and call this one move direction. And this will be a new vector3. And it will be basically this move direction that we have already defined at the top of the script. And then we want to clone this position. And then we want to go for the x-axis. Then we want to take the mobile move direction, and we want to clone this one for the y-axis. And then we also want to take the mobile move direction and clone this one for the z-axis. And then we want to check that if the move direction dot length square. So if we're actually over 0, which means that if we're actually supposed to move at all, then we first of all want to normalize it. so we don't have any crazy numbers here. And then we want to create a displacement. So we want to take the move direction and we want to clone it. And then we want to multiply it on a scalar with the movement speed and then the time.delta time. And so this will once again help us if we are using the application on different machines, because usually in games, for example, you have something called frames per second, right? And so any computer, any phone, any XR headset will run the game on different frames per second. And by multiplying the movement speed with the time.delta time, which is the time in between two frames, we kind of make sure that on each machine we'll have kind of the same movement speed. And then finally, we want to basically add to this game object the position. So we're gonna create a new vector 3 and let's put in the displacement.x minus displacement.y and displacement.z. And in order to make our player look into the direction that they go towards, we want to also create a target position. And this one will be the current position of the game object. And we want to add our move direction. And then we want to create a dummy object like this. And we want to copy the position of this game object. And we want to then look at our target position. So basically from the position that this object is currently at, we want the dummy to look at the target position. We will get then the kind of rotation, which we will call desired quaternion. And this will be the dummy quaternion, so that we have kind of the rotation vector, if you want to call it like this. So then we want to get the angle difference, which will be the current game object quaternion and the angle towards our desired quaternion. And then we want to say that if the angle difference is smaller than 0.01, which means that we only have a very small, very minute change in rotation, then we just want to copy the desired quaternion to our game object. And otherwise, we are going to do a linear interpolation by using the quaternion slurp. And we want to then take the desired quaternion and use a speed factor of 0.35. All right, so then let's also implement the check for player fell down method. And here all we need to do is to say if basically the player, so the game object position and the distance 2 and the distance from the current position of the player to the player spawn position. So I think we saved that somewhere here. If that is greater than 30, let's say, so which means that it is so far away, it's even beyond kind of what the whole game board size is, so that we don't accidentally set back the position while the player just run away too far from its spawn position. We will simply go ahead and copy to the position the spawn position. So we will reset it to the spawn position, and we'll also need to go into our rigid body and then set the velocity to a new vector 3 of 0, 0, 0. So for example, if the player fell down and then gets resetted, it will still have some kind of velocity or movement, which is controlled by the rigid body. And we do want to reset that too. And we also want to reset the angular velocity. So let's also set that to vector 3, 0, 0, 0. And so this way, I think, is an easy way to just kind of reset all these values and to spawn or respawn the player by simply resetting the position. Now finally, let's also manage the desktop controls. So up here in the update method, we want to do a little check if this is desktop. Then we want to call a method that we'll call apply desktop controls. And let's also write that method just above the update function. So we want to create a new const that we'll call move direction. And this is going to be a new vector 3. And then we'll listen to if this keys pressed is W. So we're kind of making sure now we defined this. So we defined this dictionary a bit earlier on with the key string boolean, and here we'll now kind of save which keys are currently being pressed. And then depending on the keys that are currently pressed on the keyboard, we'll kind of do some actions such as move or jump. So if the key pressed is W, then the move direction.z will add 1. Then if the key pressed is S, we're gonna add the move direction Z -1. And so this means that if someone will press W and S at the same time, the character will not move. And if the key pressed is A, then we will add to the move direction.x 1. And you probably guessed it already, if keys pressed is D, then we will add to the move direction.x, or we will subtract -1. So then if our move direction, and again we want to check for the length here, if that is above 0, so if we've actually been moving, we want to once again normalize it so that we don't have any crazy vectors here. We then want to create our displacement once again and clone the move direction and do a multiply scalar for the movement speed times the time.delta time, so time.delta time. And then we'll add all of this to the game object. So then we'll once again do the same thing as we did down below here. There's probably, I would say, a better way to do this by not having to repeatedly create code, but for now let's just make it the easy way. So we're gonna once again take the target position and all of that to basically look at. So we can just pretty much, I think, paste it over here. And yeah, once again, we create a target position along of the move direction of our desktop controls, creating a dummy object, copying the position, looking at the dummy object, and yeah, I think this is fine so far. So then what we also want to do is we want to create a new method which we'll call setup desktop controls. So we want to call this setup desktop controls like this. And here we're going to create event listeners. So this is also very interesting because we're once again combining the standard HTML event listeners that you would have in a normal website with our 3js/needle/unity project. And we're going to do a event listener to the key down. We want to bind a new method that we'll create in a second, which we call onKeyDown, and bind this. And the same thing that we'll do is we're gonna add an event listener to key up. And for that, once again, we're gonna create a onKeyUp method in a second where we'll bind this. So let's create the onKeyDown method, and we will take an event which will be the keyboard event. And here we're gonna save the key into a constant. So we're gonna say event.key.toLowercase. And then in our keys pressed dictionary that we created on the very beginning, we will put in this key and we will say that it is true, so it has been pressed. So if the key equals a space, then we'll create a new jump method because then we want the character to jump. I think we already we already implemented that. So if the key equals space, then we want to call our jump method. So we already implemented that a bit earlier on. And if the key equals, and in this case, I just gonna say K, but you could take any other key as well, then we wanna trigger shooting. And I think we also implemented that method earlier. We just didn't put any logic into this method. And so then on the key up, so let's create the onKeyUp method. We'll definitely also have to pass in the keyboard event. We're simply going to say that this key is pressed and then the key is going to be set to false. So in this way, we'll kind of check that, for example, the K key has been pressed and then has been released again. And so we start shooting and then we stop shooting again. And then of course up here in our onEnable method, we'll need to set up our desktop controls, and we commented that out a bit earlier, but now we do have basically this setup desktop controls method, which pretty much only listens to key down and key up events. And then based on these events, we'll set the key dictionary. And then in the update method, which is called every frame, when this is desktop, then we're going to simply apply the desktop controls based on the keys that have been pressed or released. Let's also reduce the jump force here. I think at the last testing we found that this was a lot too high. So we can save this, and we can immediately also open our server here within Unity and Needle, and then pressing the WASD key. So we can actually move around, we can select space to jump, and this is looking quite nice. So now we do actually have desktop controls, and we can also test this out on our mobile device. So let me quickly pull this up. And yes, so on the mobile device, we also got the character running. If we click jump, it's jumping. So this is all looking pretty well, and we're making great progress on our cross-platform WebXR/Web3D application. All right, cool. So then let's implement the XR movement. And as this tutorial is getting a bit lengthy, we're gonna switch gears here a little bit. I'm not gonna code everything line by line, but I'm just gonna basically copy and paste in some of the methods that we're gonna create. and rather explain what they will do. So let's go through all the additional logic that we will need for our WebXR movement. First of all, we need to create a serializable field of type WebXR, which will later on then drag in our WebXR game object or WebXR needle engine component. And this one will help us to access many useful information about the WebXR session, for example, or the controllers, so that we can then also kind of subscribe or read the values of the gamepad or the game controllers which belong to the Quest headsets. And then we also have a cooldown boolean, which we'll later on introduce for shooting as well. Next up, we have the handle right thumbstick movement method, and this one is going to use the WebXR, the dragged in WebXR component, trying to get the session, and the XR session is something that is being basically started as soon as the user will open up the WebXR application and click on start in AR or in VR. And then we're going to get access to the right controller or information of the right controller, and want to then specify this to the axis of the gamepad. And here we're basically going to do exactly the same thing that we've done already with the mobile joystick and with the WASD keys. So we're going to get the information of the accent Y axis basically, or the accent Y coordinates, and then we're going to apply that to the movement of the player and make them look at the specific direction or position that they're heading towards. Then the handle XR jump, and here we're going to do exactly the same thing. We're going to access the WebXR component, the right controller, and as soon as we can get the B button and it is pressed, we are going to jump. Then finally, with the shooting, we're going to get the right controller trigger button, and we're going to find out if this is pressed, and if so, then we want to trigger shooting. But we also want to introduce the cooldown, because otherwise we're gonna get a lot of bullets flying through the air, and we kind of want to limit that to 1 bullet every 0.1 second. So then below in the update method, after we check for desktop and mobile, we want to check that if this context is in VR or is in AR, which also means that there is a session, an XR session being started or already running. Then we want to basically just call all of these 3 methods, which will then control the player. And of course, as always, you can find all of the code in the video description. So then if we test it on our Quest XR device, we can enter also the local IP and of course test it out. And then if we click on enter AR or enter VR, I'm going to do the VR right now. We need to look around and we can see that we can fully move the character. So when I move the thumbstick, it will move around. It's a bit fast, but we can also fix that later on. If I press the B button, it will jump. And then of course, as we haven't implemented shooting, we will not be able to see this yet. But yeah, we already got all of the controls working so far. So in mobile, desktop, as well as XR, which already is a great progress. So then next up, we want to handle the shooting of the character. And for that, we'll need to create some kind of bullet, of course. I'm going to do that real quick. We want to create a new 3D object by doing a right click here in the hierarchy. And then what we want to do is we want to create a cylinder. And let's drag that one into the scene somewhere. And let's make this really, really small. So once again, we want to create a parent. So let's create the bullet, which will be the parent object, and the cylinder we're gonna call bullet visual. And then we want to drag that into the bullet, and we're gonna set the position to 0, 0, 0. And for the bullet, we're just gonna drag it somewhere, or maybe also just gonna reset the position for now. We can then click Shift F to zoom onto the bullet. So then the visual, we're going to make this one really small, so something like 0.01. And to see something, let's actually drag this up. Maybe this is a bit too small. We still want to be able to see it in the editor. So 0.0 to 5. This is a bit better. And then let's go ahead and again set the position to 0 and create a new prefab of the bullet. So go into the project, drag in the bullet and delete it here. And then back in the code editor, we'll need to create a new script that will be the gun controls, and we will attach it to basically an invisible point that we're going to create in front of the gun of our character. And we're gonna drag in our bullet prefab. So we are defining a force here. And then basically we have the shoot bullet method. And as long as we have a bullet prefab, we will instantiate that alongside of the forward axis, so the forward pointing axis of our game object. And then we're just gonna instantiate it, of course, make a look forward, and then basically add a impulse to the bullet. And we also need to add a rigid body, by the way, so that it will fly forward. And we're also gonna destroy it after a short delay. So we're gonna call the await destroy bullet after delay method. And so after a few seconds, we're gonna just destroy the bullet. So back in the editor, let's double click on the bullet. Then let's click here on the bullet visual. Let's remove the capsule collider because we want to add this to the parent. Then let's click on the parent, add component capsule collider. Then we want to reduce the height and the radius. So let's have a small radius like that, and height will probably also be something like 0.05 or something, maybe 0.06 and 0.02, something like that. So next up, we're also gonna add a rigid body to the bullet like this. And then we can leave the bullet prefab. And finally, we want to go into our character here, and let's see where it is. So we want to basically attach a empty game object to the front of the gun. So in order to achieve that and get this game object in front of the gun, we can actually go ahead into the Battle Royale Duo folder, into the prefabs, and there's weapons. And I think this one has the assault rifle Polyart. And then we can simply create a empty object here and call this one, let's say, gun position. And we can then add the script we just created with needles. So we do have that in the components code gen, the gun controls added here. And here we can also drag in the bullet, then take the gun position and move it somewhere so that it's in front of the gun. And then if the gun moves, this point will also move with it. So that's pretty cool. All right, now we need to, of course, still trigger our shooting mechanisms. For that, let's go back into the character controller. And somewhere down here, we have this trigger shooting from position method. And in order to actually trigger the shooting from the gun position, we of course want to create a reference to the actual script. So we want to create a new serializable field up here of type gun controls. And then we're going to call this gun controls reference of type gun controls. Then we want to go into this reference here in the trigger shoot button from position. Then we want to go into our reference in the trigger shooting from position. And we want to call the shoot bullet method. Back in Unity, let's go into our character and let's search for our gun attachment here so that we can create the reference to our character controller script. One easy way to immediately open up such prefabs in Unity is to do a right click and then select children. And so this will basically open the whole character with all the children's. And we can immediately find the assault rifle Polyart here, and we can see that here's the gun position with the gun controls. And then within the character, we want to drag in the gun position into the gun controls reference. And always remember to save in order to export it. And as you can see, if we're here in our browser, move around and press the K button, there are actual bullets flying out of the gun. Doesn't look super cool. You might need to increase the force or something, but it is working quite well. And with that, we can actually start shooting our skeletons. Same thing in VR. As you can see, we can shoot here against the wall, hitting the trigger button. If we keep the trigger button pressed, we'll also have some kind of machine gun effect here, but we can also just shoot single bullets, so that's pretty cool. And the same thing goes for the phone, so we can move around, jump and shoot. We can also, of course, move and zoom around, and then we're gonna see the shooting a little bit better here. So that's pretty cool as well. So one thing we'll definitely need to do in order to have this running in VR and AR correctly is that we'll take all of these elements that we have, so the cubes here, and we want to drag them out of the XR rig and also reset the camera to 0, 0, 0, and then take the whole XR rig and move it as basically the camera. So just move it a bit behind, so it's kind of a bit behind our game here, our playing field. If we switch into the game view, I think that's okay so far, and save the scene. Also, one thing we'll need to do in order to have this run in AR correctly and to not have this scene being very large is that we need to adjust the scaling. And we can do that by clicking here on the WebXR component and set the AR scale to something like 25 maybe. So then if we'll open it up on the Quest XR headset and enter VR, then we'll be right behind the character and we can move it around and also shoot. And then if we quit XR, and then if we enter augmented reality, we can place it somewhere and also move around with the character, and it's all nice and small and not so huge. We can shoot, we can jump. So this is actually looking really cool right here. Whoops, and we fall down. And seemingly the respawn is also working. So that's great. Now finally, let's create our enemy AI, these scary, spooky, scary skeletons over here. And for that, we will also use a very interesting method. We are going to use Unity's nav mesh system. We're gonna export it and we're gonna use it then inside of the 3 pathfinding library that we can also use because we're in a web project, and this is also something pretty cool. Let's begin by clicking here on the skeleton enemy. We're gonna add 2 components. So the first one will be a collider. So I'm gonna take the box collider and also make sure that this one fits the visual. So I would say about this size here. Let's see. Yeah, maybe a bit thinner. It's a thin skeleton, but also make it a bit wider so it will be easier to hit than later on. Like that. Okay, and then maybe a bit downwards like this. And then we also want to add a rigid body. And then within the rigid body, we want to turn off the gravity, and want to turn on is kinematic, because we don't want actually the skeleton to fall down or anything. We just want it to walk around a bit. And then we'll also want to import a new script, which I've already copy and pasted here, called the enemy AI behavior. And for that, we'll need to also import 3 pathfinding, because this is a library which will help us then to create pathfinding and have our AI walk around in the scene. For that, once again, let's open up the terminal down here and let's do npm i3 pathfinding. So after we install 3 pathfinding, let's have a very quick look here. So we do have a asset reference, which will be our nav mesh. It will bake in a second, and this will be just basically a plane or multiple planes that will more or less show the walkable area. We have an on-death effect, so a particle effect is being played once the skeleton has been hit by a bullet. And then there's basically just a normal or standard pathfinding here. So we do have a on collision enter, and this will happen that if it was hit by a bullet, which we'll need to then also assign a layer. So we're gonna do that in a bit. It's gonna respawn. And then in the pathfinding, basically what it will do is based on the mesh that it will put into the AI behavior, it will just search for a random waypoint, so one random spot, and then it will go there, and once it has finished, then we'll pick a new target. Then back in the editor, let's assign the AI enemy behavior here. And after we've attached the script, let's actually go ahead and create a nav mesh. And for that, we're gonna need the Unity nav mesh integration. So let's create a new empty object and call this one nav mesh. And we want to add a nav mesh surface. And we can leave everything as it is, I think, and simply click on bake. And so as we can see, now we do have a nav mesh surface going on here, and this one basically defines all of the walkable area that the skeleton will be able to walk. We could also, of course, go and manipulate these values. I think up here within window AI navigation, we do have a way to manipulate the radius, height, step height, and so on of the humanoid character. And if we would decrease the radius now, it could even go closer to these objects here and so on. But I think for our purpose, that's very much enough. So next up, we actually want to import a C# script that we are going to use inside of Unity. You'll also find it in the video description. And we can simply drag and drop the nav mesh exporter here into our assets. And we want to drag this script onto the same game object as our nav mesh surface component. And so we'll use this script to then export the nav mesh into basically a standalone mesh that we can then once again import within the browser view. So for that, all we need to do is click here on the 3 dots, click on export nav mesh, and then it will create a new navmesh.obj, which we'll also find here in the assets folder. So let's quickly refresh here. And here it is, navmesh.obj. And then if we drag the nav mesh into our scene, we can see that it very nicely overlays with our surface. And so we can use that actually to navigate with our AI enemies. So then let's click on the skeleton enemy, and within the nav mesh, let's drag in our nav mesh obj. And then we also need a on death effect. And for that, we can simply also again import some particle effects from the Unity asset store. And I found this magic effects free asset on the asset store. Again, the link will be in the video description, and we can then simply import it into our Unity project. So let's go to Window, Package Manager, and then in the assets, let's search simply for magic. And here we do have the magic effects free, and we're simply going to import this into our project. Let's click on the Whole Studio folder here, and then the magic effects pack, the prefabs. Then let's go to hits and explosions. And we want to select the green hit here. Let's click again on the skeleton enemy and simply put the green hit in the on death effect. We also want to make sure here that if we double click on it, we can see there's some kind of looping effect, so we don't really want that. So let's just turn off the looping here. And so if we move up the AI navigation, click on the green hit and click play, we do see here a pretty nice hit effect that we want to use. It will also probably be quite big, so maybe we want to set down already the scale in advance to something like 0.2 or so, and let's see how that goes. So then finally we'll still need to add the layer to our bullet, so we can click on assets and open up our bullet. And here at the top right we have the layer, and this is pretty handy for any kind of physics comparison. So if, for example, we want the skeleton to only explode when a certain object hits it, we can do that by using layers, and we can add a new layer, and layer 3 will call that bullet. And if we'll remember correctly, then we already in the enemy AI script we already compared for the bullet layer, so the layer 3. We can see that here in our Visual Studio Code. So in the on hit method, let's see, where was it? So here on collision enter, we'll compare if the collider layer is 3, and if it isn't 3, then we're just gonna return, and otherwise we're gonna basically then execute all of the death effects and so on. So then always remember to save, so it will actually export the scene. And so then if we open up our local browser and move a bit around with the mouse buttons, we can see that our skeleton is happily moving around. It looks a bit stiff right now, but we're gonna change that in a second. And after that, we're pretty much done. So the skeleton is finding some random points to move towards, which is exactly what we want. So then if we move towards it, let's try that out. Oh, it's running away from us. That's not good. Oh, here it is again. So if we're running towards the skeleton and shoot, let's see. Oh, I think we actually didn't assign the bullet to the correct layer. Let's fix that in a second. So yes, the bullet is still on the default layer, so we need to assign that to the bullet layer and also assign the children. Let's re-export that to local browser manually here. And now we're back in the browser, and if we shoot the skeleton right now, it will disappear, and it also should respawn. Yeah, here it is. We also saw that the particle system is actually quite tiny, so we might actually want to go ahead and make that a bit bigger again. But for our little prototype here, I think it's working great. So the final thing we want to do is add some animation to the skeleton, and for that we can open up the animator here within our skeleton enemy. So let's click on the animation controller, and there seems to be some kind of blend tree. Honestly, we're just gonna delete this. Right click delete, and then within the animator let's create a new state and simply call this walking. And as we only do have a couple of motions in the project here, it will be pretty easy to find what we'll need. So let's see what we do have here. We do have the walk motion, which is within the asset skeleton FBX walk. So this will be the correct animation to play. Let's choose this one. And then once again, let's export to the local browser and see how it's going. And here we go. So the skeleton is moving around, and we can also move around. It is walking. We can move around. We can go ahead and also shoot it. Here we go. Should also respawn here in a second. Here we go. And it starts moving again. Awesome. So the same thing, of course, goes for VR, AR, and on mobile. And here we have it. Here we have a fully cross-platform web-based game. It's of course not perfect. It's just a simple prototype and showreel of what is possible. But if you made it so far, you can really be proud of yourself. It's been definitely a hell of a journey, but this technology is so cool. And if we think about what we else can do with that, if we expand on this little game here, we could actually create something that is truly amazing. So I'm really looking forward to that. Alright, that was it for this tutorial. Definitely a lot to learn, but I think what we've built is truly amazing and shows how powerful WebXR already is. And I really hope that you could learn something and enjoy the tutorial. And as always, thanks a lot for watching and see you next time.